Another 3 minutes, we'll start. Oh, I hope you have tried this whatever I have asked in the last class. Read nicely.
Yes, sir.
Okay, I'll ask them. Otherwise, why I'm saying these things? Because next semester probably it will be completely offline. So if you not study properly, attending a class and answering and attending quiz there in a pen and paper quiz also is too difficult. Now, if you are in 9, I don't say it should be bad, but if you not read it, maybe go to 6. It will be too difficult. Please learn in your own way and try to practice, try to analyze, attend the classes, and try to understand, involve. It's too difficult. You have 2 years. Those who are past. The 6th semester, 7th semester, those who are in 6th semester, somehow they are over. But you have 1 more year. If you have practice, because 1 minute still there, if you have practice for drinking always hot water, when the cold water will come, you cannot tolerate. The same situation should not come. I thought my duty is to speak, that's why I told you. Please be careful, even if you are not applying for what online or offline, I don't know this time. But next semester probably there is no such corona, such kind of things. Everybody has to be called for the normal classes offline. And there the teacher will be pick you immediately and make you, if you little not listening and do these things, there only he will put 1 mark out of 2.
सर
हाँ.
सर उससे रिलेटेड बोले वो आंसर.
Yes, somebody else. Why you, Dipankar? You have to wait. Every time you are participating. Thanks for your that. Yes, somebody else.
Yes, sir.
We'll start
Sir,
now. Yes. Yes. What happens if it is a mutex and mutex 1? That was the question. Yes. Yes. Anybody else?
Sir, there will be a problem of, sir, bounded weight will be violated, sir.
Bounded weight. Okay.
Sir, like for example, there are 2 reader processes. The first reader processes execute still that count minus.
Okay, here it is present. Fine.
Yes, sir. So the count will become 0.
Count will become 0. Yes, definitely. 1 was there. Since 1 was there, count was 1, and this goes to 0. Very nice. Yes.
Yes, sir. So then reader process 2 comes.
Reader process 2 comes. Yes.
And then till count plus it executes.
He count plus he has execute. Okay. Now so count becomes 1 again.
Yes, sir. And then again, sir, the P1 process gets scheduled. The first reader process.
Reader process gets scheduled. Since count becomes 1, he has to skip this part, come out.
Sir. And then P2 will get scheduled, and then it cannot perform anything, sir.
It cannot perform anything else. Yes, very nice. Very nicely pointed out. Anybody else? Any other views you have thought about that? Only P2 process will not in P2 process will means R2 process will not involve, or nobody will be involved?
Sir, nobody, sir.
Nobody. You are saying nobody. Anybody else answer?
Sir, can it happen that that P1 process is before that line, that P of WR, that if
Yeah.
count, yes sir, inside that if before that P WR, there P1 is there waiting, and in P2 it is in between that if what is that int if count is equal to 0 and v of
Here.
WR, yes sir.
Here.
Sir,
Okay.
then sir, if the means, yes sir, if the P1, that first one, if it means lock it means W minus minus, then sir in V2 it will also becomes plus plus. Means yes sir. So then there can be error.
Okay. Yes, that is on another issue. Fine. That's correct. Anybody else? Last, then I'll explain. Almost you have told the same thing. I'm just going to explain for others. I'm not knowing something extra. Okay. I have also thought after the class gets over, and there also I thought, and I found some answer what you people have told. Okay. So no problem. I'll just explain what these two students has explained very nicely. So let's take R1 is here. Okay. If R1 is here, our only one reader is present, means he must have crossed through this. So count becomes 1. Yes. Then he has to be come out. When he's come out, then he will make this count minus minus. So count becomes 0. The count is currently 0. And after that, the context switching is happening, because this is a code and this is one kind of lock. So he has entered into this lock. So nobody can enter here. Only this R1 is currently present by making the count to be 0. Since he has made this count to be 0, another R2 can eligible to enter. Yes or no? Why? Because he is using a mutex 1 as a semaphore and he is using a mutex as a semaphore. Since mutex and mutex 1 are the different semaphores, even if both of them are binary, so one R2 can enter. If one R2 can enter, what happens then? At this point, can anybody tell me what should be the WR's value?
0, sir.
No, it will be 0.
Yes sir.
Yes. Yes, very nice.
Yes.
It will be 0 because WR was initially 1. He must have crossed through this. WR is 0, so that nobody can enter at that scenario. So that's why the WR is 0. So R2 can easily enter because it is a mutex. Anybody cannot enter here, but R2 can enter here because of this different variable. Once it is entered, he makes the count plus plus. So count 0 goes to 1. Now count becomes 1. When count becomes 1, he may execute this one. So let's take till now context switching has not happened. If you can consider, then count is equal to 1 means 1 is equal to 1 true. True means PWR. It is executing. So what is the PWR says? The PWR will says it is now goes to -1. Correct or not? And with this -1 we have studied, it will be go to a lock waiting queue. If S dot value is less than 0, it is going to a lock waiting queue. Means this R2 is currently slipping in this lock waiting queue. Then what will happen? Nobody can else enter. Why? He is inside this mutex. Nobody can extra will be inside because he is present inside the mutex. Since he could not do anything and he has gone for sleep, definitely the R1 will be again activated and start running. So he will run, but the count is 1. Since it is becoming 1, 1 is equal to 0 is false, he skipped. Once it is skipped, he comes out also. He comes out easily because he has not executed this, that's why he comes out. So when it comes out, now see the scenario, who can enter? Nobody can enter here because we assume that nobody is present here. Only the possibility is that the new reader can try to enter. new writer can try to enter. New writer cannot enter. The reason, because WR value is -1. With -1, nobody can enter here. And similarly for this, no reader cannot enter. What is the reason the no reader cannot enter? Because your R1 is still present here. He has not opened this lock. Since he has not opened this lock, nobody cannot enter here also. And who is present? He is the only fellow who is present here, but in a sleep. He is in the sleeping mode. Since he is in the sleeping mode, neither he get a chance to come out, nor he allow anybody to enter into him. Means there is some kind of a no progress gets happening, because he is creating such a deadlock scenario that neither he comes out, because nobody is there to make the WR to be 1 so that he will come out, because WR is still -1. This can be 1 when somebody will come here. So he cannot, nobody is coming, nobody is entering here, nobody is entering here. So everything gets blocked. So that is the scenario will happen if you are considering this is become mutex 1, this is become mutex. But if both becomes mutex, last class we have studied, it is working. Yes, in some sense.
सर
Yes.
सर ऐसा भी बोल सकते हैं ना कि अगर दोनों अगर सेम रहा तो सिंक्रोनाइज रहेगा, कोई मतलब कोई एक प्रोसेस से माइनस माइनस कर पाएगा और प्लस प्लस कर पाएगा?
नहीं कर पाएंगे, क्योंकि अगर कोई यहाँ पर है, यहाँ कोई नहीं आ पाएगा।
हाँ सर भाई।
Yes, correct. If that is your view, that is correct, because it is the same mutex. Now, अगर इसको हटा देते हैं, it is the same mutex. If somebody is present inside this, nobody is present inside this, because you are using a same kind of lock.
Yes.
If somebody has entered, means he has made the mutex to be 0. If it is mutex to be 0, nobody can enter here with 0 mutex. A positive mutex is made. Okay, that's right. Fine, thanks. This one is basically another one, that is dining philosopher. You have studied that this is a solution, but this solution has few problems. The first problem we have identified: if every process, all P0, P1, P2, P3, and P4 will execute this first statement and become context switching, then what happens? For each spoon or the chopsticks, whatever the semaphore you have taken, that is a binary semaphore, this binary semaphore becomes reach at 0, because P of S0 make it to be 0, this to be 0. P of S1 make this to be 0, this to be 0, this to be 0. See, every variable will become 0. Then if every variable will become 0 here, then can anybody will be able to execute this statement? No, means it is a deadlock scenario. Then what is the solution? What is the proper solution? So they have given 3 basic ways to find a solution. So we'll discuss and then we'll write down the code. It is very easy. Only one code will be little difficult, otherwise other 2 are very simple. So the first one is saying maximum allow maximum 4 persons or philosopher to become hungry. Yes, what does it mean? He is saying you don't allow the 5 persons to be eat at the same time. Rather, maximum 4 you allow it. Then what's the benefit? The benefit is very simple, that if I'll allow, if this is this, so this is 1 philosopher, 2nd philosopher, 3rd philosopher, 4th philosopher, and 5th philosopher. If you can consider this one. Yes, if you can say only 4, except 1, if only 4 will be happening, either this, 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 and this. Assume that these 4 are now ready to eat. Then what will happen? If you apply this code somehow here, then you can say, sir, the context switching may happen here. If the context switching will happen here, then what is going to happen? He can achieve this spoon, he can achieve this spoon, he can achieve this spoon, he can achieve this spoon. Then which spoon is vacant? Still this spoon is vacant. What is the reason? Because he is not at all interested now, because you are saying maximum 4 persons to be allowed here. So at least 1 spoon khali reh jayega. If 1 spoon become vacant, who will get a chance to get it? This fellow. Once you'll get this spoon here, what will do? He will eat. After eating, now he is satisfied. He is not hungry. After that, he will release this one and release this one. If once it will be released both the spoon, then who is ready to take? This fellow who has already received one spoon and waiting for this spoon, now this spoon is free. So he will get it and free. Then he will release this one, also this one. Then who is waiting for this spoon? This particular fellow. So he will get this one. Then after that, he will release this spoon and this spoon. Then who is waiting for this spoon? He is waiting for this spoon. Once you will get it, then definitely this is released and this is. So all four are able to eat nicely one after another or not. So there is no question of there is a deadlock scenario occur if maximum 4 persons will come out. So how we can make it? How you can write down the code for this? You can simply take a semaphore. What is saying? You allow only max 4 persons to be allowed. Means before this we apply something. After this we apply something which will tell you that maximum 4 persons will be done. Then what's the idea? You can take a semaphore that is a max, and with this max p becomes 4, and you can apply here p of a max p, and you write down that code, and v of a max p. This is a sample code. You can think about this or not. Means you are allowing only 4 persons to at a time think. If it is, then there is no error. Okay, this is one choice. The second solution he is giving. I hope you have understood. Yes, just the bottleneck principle. If there is a 4 pigeonholes and there will be a 5 pigeons, so there is a possibility that one pigeonhole, in one pigeonhole 2 pigeons can be included. How you are doing? So you are just dividing whatever the remainder that can be included in one of the pigeon. The same thing is happening here. If 4 persons are maximum selected for eating purpose, if everybody, even if anyone will be take 2 chopsticks, no problem. But if everybody is taking their first chopsticks but not able to get the second chopsticks, then what happens? At least one of the chopsticks will be free because he is not at all allowed to think. If he is not allowed to think, this chopsticks will be definitely free. If it is free, then he can use this, both will be available, he can eat, then release it. Then once this is available, he will take and release it. So like this, the whole thing gets continued. So this is one. The second solution is very interesting solution. He's saying, now you have to think, you allow the event philosophers. Will take left chopsticks first, and then right. Similarly, odd philosophers will take right chopsticks first and then left. So what was the basic meaning he's saying? He's saying that if it is the same thing, so this is 1, 2, 3, 4, and 5. So if this is the philosophers, they're saying it is as a P0 philosopher, P1, P2, P3, and P4. He's saying if P0 is a even, either you can alternate also. The odd will be first take left, even will be first take right. Anything will be possible, but it is an alternate one. So P0 will be take its left, because 0 if you consider as even, then he will first take this, and this P1 will first take this. Okay, then P3 will be, P2 will be again what? Even. So since it is even, he cannot take this one because already he has taken this. Then P3 can it take it? The P3 can take is right. Right means this one he has taken. Okay. And what about P4? The P4 cannot taken because both of them are taken. Because P4 is desired to take this left chopsticks. He has not taken. already this fellow has taken, then which one is free? This is free and this is free. Why it is free? Because P1 first consume this one, right one. Since it is right one, this becomes free. Because P0 is left hand side, philosopher is first taking this left one. Since he is first taking the left one, then this will be become free. If this will be become free, who will get a chance? Either P1 or P0. If any one of them will get a chance, what will do? If P0 will get a chance, definitely he will use this, then after release. After he is releasing, he can easily take it or not. So there is no kind of a blocking will be happening here if you apply this rule. Then what code you have to write? Only you have to change this particular code here and this particular code there. So what is the changes? The changes are very simple. So you can say if our I modulus 2 is equal to 0, yes or no? Means if it is an even philosopher. If it is become even philosopher, first it takes the left one. So first it takes the left one means he is saying P of you are doing here S of I. So left is S of I. And then P of S of I plus 1 modulus 5. This. Else you do opposite. Then P of S of I plus 1. Sorry. Modulus 5. Then P of S. Sufficient or not? So like this, you can write the second part. So what it indicates, he is saying, if it is an even philosopher, first you pick the left one, then you pick the right one. If it is an odd philosopher, first you pick the right one, then you pick the left. So this is one more solution. And another interesting solution he has given, that the solution is basically, if the philosopher has got two chopsticks, then only he can pick up. He cannot pick up a single chopsticks and after that another chopstick. No, if both will be available, he will pick up, otherwise not. Means he's saying if both chopsticks are available, then only the philosopher will pick up. Yes, he's saying if both will be available, then means left, right, both done, then only you can do it. So there will be no issue, because here there is no kind of a blocking will be happening, because if left is available, right is available, then only I take it, otherwise I have to wait for some time. So that any other people will be definitely get a chance to do it or not. So that is the idea. Then how this can be implemented. So this requires a little bit tricky implementation. Yes, please.
सर if कर देंगे, if से चेक कर लेंगे पहले.
नहीं, if से आप चेक नहीं कर पाओगे. if से आप इतना इजी नहीं है if से चेक करना. आप बोलोगे कि ए अवेलेबल है, जब चेक करोगे कोई एक ले गया. Yes,
picking up part we will put a mutex.
No, because if you write a P mutex, a P some S of I, and you have to check what S of I plus 1 of this.
रैंड कर देंगे दोनों को.
Yes, ए नहीं कर पाओगे, क्योंकि ए अगर एग्जीक्यूट हो गया, ए ऑलरेडी एस ऑफ आई को 0 कर दिया होगा.
Sir, before sir picking up, we will put a mutex, sir.
No, now what you do, if you put a mutex, then you are not allowing anybody. Only one people will be allowed at a time. Then there is no meaning, no?
सर अगर एटॉमिक कर देंगे.
No, in his answer he was very interesting. He is saying before this you put a mutex. But what is the problem? The problem is if before this you put a mutex, then you can indirectly say, here that you will allow only one philosopher to eat at a time. Am I correct or not?
Yes, sir.
If I
No,
apply
sir, while sir picking up after picking the chopstick up, you will sir release the mutex.
Then the same thing will happen, no? If you are saying that after this, if everybody will be come here, suppose one is available, you have entered through this mutex, one is available, then you do it, but this is not available, then what will happen? You yourself is blocked.
Sir, if one is not available, sir, then अच्छा हाँ, yes sir.
ठीक है कि नहीं, क्योंकि यहाँ पर अगर मैं म्यूटेक्स पी म्यूटेक्स लगाऊंगा, यहाँ पर भी म्यूटेक्स लगाऊंगा, पी म्यूटेक्स के थ्रू तो आप चले गए, बट ये नहीं मिल रहा है, ये मिल गया, ये नहीं मिल रहा है. Like this, if the three processes will be like this, again everybody is in the but no.
सर
हाँ
सर को ये इफ को अगर एटॉमिक कर देंगे, मतलब ऐसा चेक करेंगे इफ एस ऑफ आई एंड एस ऑफ आई प्लस वो जो भी है वो अगर हुआ तो ही हम लोग लॉक करेंगे.
वो नहीं कर पाओगे, because this semaphore variable cannot be normally checked by a if condition. Even if it looks like a integer variable, you cannot do as a if condition. What is the reason? If you put a if condition with si is 0, si s1 is 1, s2 is 0, like this you can check it. No, this is not a single statement. This is a number of a multiple instruction, and there is a context switching in the middle also.
Okay, sir.
Yes, so only possibility. What? 1 minute, please wait. Yes. So that's why it is not possible. Then one may think about, sir, why don't you write another P operation where the two semaphore variable can be checked properly? It is not so easy. Because writing a single P with a single semaphore is too difficult. When you'll see the code, one day I'll show you the code, how the P operation itself is written. We have just shown that it is becoming an atomic, but how this atomic will be applied? One can say that, sir, why don't you write a P operation with two variables? And this will say that this and this both will be available, then only it will be allowed, otherwise not. So that we have not written. If it is not written, because P and V operations are already available by the operating system, with the P and V operation with a single semaphore variable, can you apply this rule that if both chopsticks are available, then only you will do it, otherwise not. Then how this code is? This is not my code. This is a generalized code, is present everywhere. It is present, but only understanding is important. Just look into it, what is happening. So what he has done, he has taken three different functions. So first function is the philosopher. The philosopher has to work. Yes or no? Which philosopher? ith philosopher. What he wants? He wants to do a repeated work. So while one, the same style code, no change, nothing. Little changes, I'll make it time to time. Yes, and what is doing? Thinking like this. So how will think? Sir, he is thinking by think of I. Sir, he will eat by eating of I. But before eating, he has to be take the chopsticks. अगर दोनों available हुआ, तब जाके खाएगा, नहीं तो नहीं खाएगा. So what is? He has to be take the chopsticks. And after this, he has to release the chopsticks. Yes. Now what you do? You have to write some function, how to do this check chopsticks and how to do the release chopstick. And what is this check chopsticks work? If two chopsticks are available, left and right chopsticks, then only I can able to eat, otherwise not. Then how he has written these things? He is saying that you write a function called as a take chopsticks. Oh, fine. So check chopstick. So what he's saying, you have to, before going to the check chopstick, he has taken some few states of each philosopher. So he has taken a enum, and he is become hungry, or become eating, or it is thinking. Yes, these are the three states of the philosopher. Yes, along with this, he has taken one more thing that is called as for semaphore for each philosopher. What the each philosopher is doing. So semaphore P of 5, and each one will be initialized with 0. means P0, P1, P2 means nobody is doing anything. So with this P0, P1, P2, one cannot enter into a critical section. Yes. Along with this, he has taken one mutex variable. So mutex become okay. So he has taken mutex is 1, and this is the semaphore for each philosopher, and these are the states for this. And what this tech chopsticks is saying, the tech chopstick is saying, I want to take the chopsticks, then only I can go for eating. But before taking the chopsticks, he is saying, first I have to tell me what is my state. The state has to be also, he has to be same. So he is creating a one more variable called as the int state. Int state of I. Yes. So before taking this, he is saying you change the state of I to be hungry. Yes. So he is saying I am hungry. Then he is saying you taste it. Whether you are allowed to take the chopsticks or not. Well, if both will be available, then only I can take, otherwise I will not take. Yes, he is saying like this. Then first he is saying I am hungry, then he is saying please taste whether this ith process or ith philosopher can take the chopsticks or not. Then how the test function has written. So the test function has to be written, we all know. What he has to check? He has to check a few things here. The first things he has to verify that he must be hungry, because if he is eating, he cannot test it. If he is thinking, he cannot test it. Only he can test for the spoons, provided he is becoming hungry. So what you can do? First criteria comes, his state of I should be equal to hungry. If it is, the second is saying, the my left person, if you can look into this figure, yes, if this is the 5 philosopher, please ask me if you have a doubt. This is P0, P1, P2, P3, P4. He's saying, I am hungry. If I am hungry here, if this is not eating and this is not eating, guaranteed these 2 chopsticks are available. Am I correct or not? Yes. If he is not eating and he is not also eating, then guaranteed these 2 chopsticks are available. Means I can able to eat. Very simple criteria, test criteria is that. The test criteria, again I am repeating, he is saying I should be hungry and my left and right philosophers are not in the eating state. They may be hungry, doesn't matter, because if they are hungry, they have not picked up the chopsticks. If they are thinking also, definitely they don't have the chopsticks. So that's why he is adding 2 more code, that is your state of, you have to help me, test of something has to be not eating, and this is and again and state of something should be not eating. If it is, then I can able to do this. Then I can become eating. Yes. Anything wrong?
No, sir.
So if this is hungry, this is not eating, and this is not eating, then only I can say the state of I becomes eating. That is the basic idea or not? Then who is my left side? Who is my right side if it is become I? Can anybody quickly tell me? Who is my left side and who is my right side?
I and I plus 1.
No. I and I plus 1 always?
I plus 1 mod 5.
I plus 1 mod 5 is 1 and another one?
I.
I is 0. Next philosopher is 1. For 0, for I is 0, it should become 4 and 1. For I is 1, it should come 0 and 2. For I is 2, it has to become 1 and 3. So what should be this?
I plus 1.
Only I plus 1? No. 4 plus 1 is not 0.
सर लेकिन एरे तो वैसा है ना कि वो 0 के लिए 0 है और उसका बाद का +1 है.
मैं आपको सिंपल सा बताया. If it is my ith process, I becomes 0. I want to know about which is my right eye, which is my left eye. Tell me a formula, quick. You are in 4th semester.
Sir, n minus I minus 1 mod n.
What is n here? Only 5 is there.
Sir, 5 minus I minus 1 mod n.
5 minus I minus 1
Mod n, mod 5.
mod 5. Is it satisfying for all? Check. It is left or right?
Left, sir.
It is left. Check for the 4th one. Means indirectly you are saying the 4 minus I modulus 5. Am I correct? 5 minus 1 is 4, 4 minus I modulus 5. Is it happening? If I becomes 4, 4 minus 4 is 0, 0 modulus 5 is this, right? As per this line, it is right for this 4. Yes? Quick. These things you have to support me. What is simple is, one is I plus 1 modulus 5, one is I plus 4 modulus 5. Check. Is it satisfying? Check. It will satisfy. Because if it is becoming 4, now what is the 4? 4 plus 4 is 8. 8 modulus 5 is 3. Then 4 plus 1 is 5. 5 modulus 5 is 0. Take a 2. 2 plus 1 is 3. 3 modulus 5 is 3. 2 plus 4 is 6. 6 modulus 5 is 1. Okay, it is satisfying. So what to write? You have to write I plus 1 modulus 5. I plus 4 modulus 5. Okay, no, this is not a big task for all of you. Once it is done, yes.
सर लेकिन थोड़ी देर पहले आप बोले थे कि वो होगा ना, वो पी नॉट तो अपना लेगा, जो उसका लेफ्ट है वही उसका अपना
वो chopstick लेगा. I am not considering chopstick. There is no question of chopsticks here.
ओ
There is no
पर्सन का है ये.
question of chopsticks. Only we are checking that my philosophers are eating or thinking or hungry. There is no chopsticks semaphore. Only philosopher semaphore. Got it?
Yes, sir.
Yes. Because you are thinking that there are chopsticks named as a 0, 1, 2, 3. That's why you told in that way. But here there is no chopsticks. Because we are considering if my left is not eating, right is not eating, means chopsticks are free. That's why I can take it. Yes?
Okay.
So
Yes.
once it is done, once this is done, then my first work is over. But what is the use of this one? Because I able to understand what is the test, then he can become tested and he is going on. So what is saying, after you becoming eating, then you yourself has to be tell that now I am ready. Means he is saying you can make a P of this P of I. Means this P of I operation को आप क्या कर रहे हो? Sorry, B of. This is B of I. Means I increase this P of I, means he is now can able to eat. I made it. So in the same manner here what it does, since everybody can enter and try to make a test, that's why he is putting a restriction. How he is putting a restriction? He is putting P mutex and he is putting V mutex. So that only one person at a time can test. 2% अगर टेस्ट कर दिया तो दोनों को फ्री मिलेगा, दोनों उठा लेंगे. अगर वो सोच रहे हैं P0 भी टेस्ट कर रहा है, P1 भी सेम टाइम टेस्ट कर रहा है कि दोनों है, तो this one is common for both. Suppose this is free and this is free and this is also free. Now what happens? The P0 also thinks that 2 chopsticks are free for me. P1 also thinks that these 2 chopsticks are free for me. Then both will go for eating, which is violating the rule. So that's why what he's saying, while testing, you make them in this state. Then after you make this testing, there are mere 2 scenarios. What is the 2 scenario? One scenario is that the person who is testing, he is allowed to eat, and the person who is testing is not allowed to eat. If he is not allowed to eat, he has to wait for further testing. So that's why since he'll wait, he is making P of I. Because my P of I initially is what? 0. If he is not able to get a chance to eat, then definitely I will do it here. Because P of I becomes 0 at the very initial stage and this. But if you could able to eat, now what is the beauty of this? Just see. If he could able to it by this testing feature, then he is testing. This V has increased. Since this V becomes increased, then what will happen? Now again it will be decreased here, because by P operation it will decrease and V operation it will increase, and again this balance goes to 0. So this is my take chopsticks and a test. And what is the other one? The other one is becoming
तो वो ऑपोजिट नहीं होगा, वो P उधर रहेगा और V इधर रहेगा.
ऑपोजिट करके एक बार दिखाऊंगा. क्या प्रॉब्लम होगा आप लोग बोलोगे? अभी दिखाऊंगा. हाँ, वेट कीजिए. अगर मैं इसको भी मान लेता हूं एंड इसको P मान लेता हूं, क्या होगा बोल पाओगे? अगर इंस्टेड ऑफ V आई पुट ए P, इंस्टेड ऑफ P आई पुट ए V. सपोज इसको खाने के लिए मिल गया, क्या होगा यहाँ? एनीबॉडी प्लीज?
होगा.
नो, डिक्रीज होने से क्या होगा? ये बाहर ही नहीं आ पाएगा.
स्लीप होगा सर. Sleep.
Because he is going to sleep, he cannot come out. What is the reason? Because this PIE is becoming sleep. Why you will go to sleep? खाना खाया, think करना चाहिए. सोने के लिए क्यों जा रहे हो? अच्छी तरह से होटल में खाए फिर काम कीजिए. So इसको भी वही मिल जाएगा. If it is becoming P operation here, since you have taken the PI becomes 0, he has tested, he is allowed to enter, he is eating. After eating, since PI becomes 0, he is going to sleep. Or he could not able to go further. That's why what he does? He does that. Why don't you make it here B and here P? So if you make it here B, there will be no issue. खाने के बाद तुरंत बस P को बढ़ा दिया, एक increase कर दिया. But here the importance comes here. Once he eat these things, come out by mutex, then he immediately reduce it, because go to the original position of PI becomes 0. That is one case. Another interesting case, how to release these chopsticks. So while releasing, yes, by I, then what he has to do? Definitely multiple persons has to be released. So you don't allow multiple persons to be released at a time. So that's why you can also use here P mutex and V mutex. Why? Because while you are somebody enter here for testing purpose, one cannot release. If same time entering, same time release, always the same chopsticks will be make a inconsistency. That's why he's saying you make this P and V with the same mutex and mutex and mutex. But what is the work? When you are releasing, means eating is over. Then what should be your state? The state of I should be goes for thinking. Yes. Then what is the next one? After you become eating and release the chopsticks by telling thinking, you have to tell to your neighbors that मैं release कर दिया हूँ, आप लोग खाना खा सकते हो. Yes, no. Once this P0 has taken his food properly, then he has to be informed to P1 and P4 that now you can take test for whether you have a chopsticks or not. Because it may happens while P0 is eating his food, the P4 may have this chopsticks, but this is not available. The P1 may have this chopsticks, but this is not available. But the moment P0 free these two chopsticks, when he's saying I am now thinking, then definitely he has to be informed to P1 and P4 that you have to do it. Why he has to be informed? You can say, what is the reason of inform? Sometimes what happens, while he is eating, while he is not eating or eating, somebody, while he is eating, then somebody may have entered and come to this place that he is hungry, but not able to get the chopsticks. In those scenarios, this particular thing will work out by checking that a test for I plus 1 modulus 5 and a test for I plus 4 modulus 5. Means this statement is saying once you become away from the eating to thinking, then you please call this left process and right process to check their own way whether they can able to enter into this eating purpose. Okay, so this is whole about this code. Yes. Now, very, very important thing you may it will be raised in your mind, sir. Why this test? How this test will work? because test requires a hungry. How he become hungry? There is one question may raise here. Sir, if I am going to make that test some process, but I am a different process, I'll tell to somebody to test it. But how this test process become hungry? The test process become hungry if he himself has entered into this area. But is there any possibility that he himself has entered into this area? Yes, it is possible. How is it possible? Just look into it. While somebody is eating here, then can any other fellow will be enter into this area?
No, sir.
No. Why not? Why not? Why not others? Why not? Because test is written inside a P and V mutex. So when the test become calls, still your mutex lock has not opened. Unless until this is going to be over, this lock cannot be opened. So what happens? Suppose P0 enter, eating here, while it is eating, after eating, he has done these things. Now he come to this place, but he has not performed this operation. Since he has not performed this operation, now one more person, suppose P4 try to enter. When P4 try to enter, now the mutex are open. Since mutex become open, the P4 can enter. Check that he is saying that I am hungry. But can this able to get the test, valid this test? No. Why? Still my P0 is in the eating state because he has not released his chopsticks. If he has not released his chopsticks, the test function of I will not work for the fourth process because this is my P0. P0 has already taken his eating, finished this test function, but not executed this line. He is still here. Still here. Since he is still here, then what happens? Basically, it happens that another P4 process try to enter into this eating state. If you want to enter, he himself make it hungry and go for testing. While he is go for testing, he is checking that I am hungry, but my right process is not in not eating state. Rather, he is in eating state. Since he is eating state, this condition will be false. If the condition will be false, he will not enter into this. Then come here. While he come here, he come out. While he come out, he is waiting here. Who is waiting here? P4 process. Then what the P1 has to be do? The P4 is waiting. P0 is context switching here. Then P0 comes here. Make this P operation nicely because he has already changed this 0 to 1. Now it is become 1 to 0. Now after doing this take chopsticks and eating purpose, now he can able to release it. While releasing, now look into it. He is saying, I am thinking. Who? This P0 is saying, I am thinking. Then he is telling to my left and right process, now you can test. Can your right process will be allowed to test here? No, because till now my P1 process is not interested to it because he has not executed the hungry statement. Means for P1 it will not execute, but for P4 it will be execute. How nicely it will be execute? Just see, for P4 he is calling. Who is calling the P4? P0 is telling that P4 you please test this. Then the state of 4 is hungry because he has already come down through this 2 lines. This P4 he is waiting here. Then he is checking, can my P3 is not eating? Yes, not eating. Can P0 is not eating? Yes, not eating. Why is not eating? Because he himself has changed the P0 to be thinking. Because P0 has changed himself to be thinking. So he is not eating. He is not eating means P4 will be allowed. So what is doing? He is in the eating state. After he is eating state, now this B operation increases value from 0 to 1. Whose value? P4's value. Since P4 was waiting here, then now he can release from here because this makes you 1, then he becomes now 1 to 0. So in this way, these two things are working. So very simple way to understand and remember. This part everybody knows. Only this part and this part creates a confusion. So here the basic part is I have to become hungry and I have to test. While testing, 3 criteria. I should be hungry, my left is not eating and right is not eating. Then only I can go for it. And while releasing these things, I have to tell myself that now I am going for thinking and I'll tell my left and the right process that now you are free to enter into the you can enter for the eating stage since I have released my chopsticks. That is right. So this is the code through which hard condition gets satisfied. Yes, ask.
सर इसको प्रोग्रामेटिकली कैसे इसको बना सकते हैं?
एग्जैक्टली पूरा ऐसे लिखेंगे, प्यूमिटेक्स जो होगा प्यूमिटेक्स लिखेंगे, यहाँ पर एक एनम ले लेंगे, यहाँ पर इंट स्टेट ले लेंगे, एग्जैक्टली यहाँ ये तो कोड मिलता है, फिर भी आप देख पाओगे कैसे लिखा गया है. Since you have asked that I have executed few codes in the previous year or some year, I don't know which year. So you go to this, go to my course, this OS, few programs, synchronization, DP, dynamic philosopher. Yes, if you can go for this, see here, exactly we have checking that if my I should be hungry, the same I, that a ph norm I should be hungry, and my left is already written here, I think. Yes, left is written here as a 4 and the right is written as a +1. So if my left is not eating, right is not eating, then I change to this and say that I am doing something. I am doing something and go for this one. This is my test. Yes or no? The same post means it is a B operation. Okay. So same weight, and in your C programming language, when you use the POSIX thread, in the POSIX thread, there is a same weight and the same post. Same weight means it is basically a P operation. Same post means it is a P operation. Okay. And these are my semaphore variables. Somewhere I must have taken. Yes. If you can, this is a philosopher where I have taken semaphore variables. Semaphore variables somewhere I must have taken.
वो वाला SEM 40.
And इसको भी कहीं पर इनिशियलाइज कर रहा होगा इस वैल्यू को.
वो SEM init.
हाँ, जीरो इनिशियल, ठीक है ना. बट यहाँ पर देखिए कितना इनिशियलाइज कर रहा हूँ, 1 इनिशियलाइज. म्यूटेक्स में 1 इनिशियलाइज कर रहा हूँ, यहाँ पर 0 इनिशियलाइज कर रहा हूँ. सो द सेम वर्क. आई क्रिएटेड मल्टीपल थ्रेड. हाउ मेनी थ्रेड्स? 5 थ्रेड्स. ईच थ्रेड्स का काम क्या है? फिलोसोफर फंक्शन को कॉल करेगा. फिलोसोफर का काम क्या है? क्या करेगा? टेक चॉपस्टिक करेगा, फिर स्लिप करेगा. स्लिप मीन्स हियर ईटिंग. Here the sleep means I have not eating means here basically I have to write a printf statement. Yes, that's why I have made this. And a put means give the chopsticks. And this part you can think of a thinking. So this is my thinking, this is my eating, this is my take the chopsticks, this is my release the chopsticks. Okay. In the take fork also same. I have to make a mutex lock, then vmutex lock. And inside this what? I told that I am hungry and call the test function to do this. Yes or no? Exact or not?
Yes sir.
Same thing. So nothing, we are not reading.
सर इसका हेडर फाइल क्या है? वो SEM.
ये सब आपको मिल जाएगा तुरंत. एक पी थ्रेड को यूज करोगे तो सब कुछ मिल जाएगा. एंड सीमाफोर से आपको जो पोस्ट एंड वेट मेथड आपको मिल जाएगा. यहाँ से पी थ्रेड्स आपको थ्रेड मिल जाएगा, सीमाफोर से वेट एंड इनिट एंड पोस्ट मेथड मिल जाएगा. ठीक है.
यस सर. सर और एक डाउट है कि सर ये कॉन्टेक्स्ट स्विचिंग हो सकता है जब एक फंक्शन को कॉल किया है, मतलब ए के अंदर बी को कॉल किया और तब एक कॉन्टेक्स्ट स्विचिंग हो सकता है?
हाँ, क्यों नहीं हो सकता है? अगर यहाँ पे टेस्ट फंक्शन को मैं कॉल किया, कॉन्टेक्स्ट स्विचिंग यहाँ हो सकता है, यहाँ भी हो सकता है, यहाँ भी हो सकता है.
मतलब एग्जीक्यूशन होने से पहले उसका बॉडी से, मतलब वो टेस्ट अंदर आया और वहीं पे रुक गया, मतलब पॉज हो गया.
मतलब यहाँ आया पॉज हो गया. हाँ, यहाँ हो सकता है. लेकिन क्या पॉज होने से क्या फायदा होगा? कुछ फायदा औरों को नहीं होगा. क्यों नहीं होगा? क्योंकि जो लोग यहाँ आने के लिए चाह रहे होंगे यहाँ पर फंस जाएंगे. Then what will happen? Again the CPU has to be context switching from the person who is now put in this lock. Then he will give it to the another. Again the person who is sitting here, he will get a chance once again.
Yes sir.
कॉन्टेक्स्ट स्विचिंग लेकिन होगा। कॉन्टेक्स्ट स्विचिंग क्यों होगा? क्योंकि हम जो कोड लिख रहे हैं तो नॉर्मल सी कोड है ना, कहीं पर भी कॉन्टेक्स्ट स्विचिंग होगा। ओनली हम लोग रेस्ट्रिक्ट कर रहे हैं, I cannot allow anybody to enter here because the p mutex will not allow. But once I come here, every place there is a chances of context switching. यहाँ पे भी हो सकता है, यहाँ पे भी हो सकता है, यहाँ पे भी हो सकता है, कहीं पर भी context switching हो सकता है।
सर ऐसा कोई एरिया नहीं है जहाँ पे कॉन्टेक्स्ट स्विचिंग हो ही नहीं सकता?
Context switching नहीं होगा मतलब आप लॉक लगाओगे पूरा का पूरा।
सर बिना लॉक का मतलब कोई रेस्ट्रिक्टेड एरिया?
कॉन्टेक्स्ट स्विचिंग नहीं हो पाएगा, हम लोग पढ़े क्या है वो, इंटरप्ट डिसेबल कर दीजिए।
हाँ
वहां पर नहीं होगा, एक ही नहीं तो कॉन्टेक्स्ट स्विचिंग होगा,
ओके
आप
सर।
बंद नहीं कर पाओ, ठीक है ना?
Yes.
सर
यस पूछिए।
सर sir, that I told na a few minutes ago, sir, mutex we will put before taking the fork, sir. I think that will work, sir.
कहाँ पर?
सर बहुत पहले सर, मतलब ऊपर सर।
वो थोड़ा बताइए। कुछ नहीं, ऐसा कुछ नहीं, मैं भी सीख रहा हूँ, ऐसे मत बोलिए कि मैं सब जानता हूँ, मैं जो बोलूंगा
सर हाँ ये पे सर थिंक के बाद म्यूटेक्स और pi+1 mod 5 के बाद म्यूटेक्स।
वो अभी देख, अभी लिख लो, अभी आपके सामने ही लिखेंगे ना, फाइटिंग करेंगे तब जाके तो मजा आएगा। सो हम लिखेंगे कि आप बोले थे कि p म्यूटेक्स लिखेंगे, क्या प्रॉब्लम होगा आप लोग भी बताओगे, मैं भी सोच के बताऊंगा। हाँ, आप बोले थे कि यहाँ पर सर p ऑफ si कर दीजिए, फिर आप p ऑफ s ऑफ i+1 मॉडुलस 4b 5 है ना, 5 कर दीजिए। फिर हम यहाँ पर एडिटिंग कर रहे हैं।
नहीं सर, उसके पहले म्यूटेक्स सर।
हाँ, यहाँ पर एक भी रहेगा, भी म्यूटेक्स से करेगा, ठीक है, भी म्यूटेक्स से करेगा, फिर यहाँ पर p म्यूटेक्स रहेगा।
नहीं सर, वहां पे म्यूटेक्स नहीं लगाएंगे।
नहीं लगाएंगे, यहाँ पर भी फंस जाओ, लगाना चाहिए, ठीक है ना? ओके, नो प्रॉब्लम, यहाँ पर हटा दीजिए, ये बात का बात है, वो सोचेंगे। सो ये भी था हमारा, एस ऑफ आई था, पूरा कोड थोड़ा लिख लेते हैं, इतना ही। सो एस ऑफ i+1
सर वी
गलत कर दिया, हाँ भी, ठीक है ना? ओके, इतना हो गया। सो अभी देखते हैं कि यहाँ पर क्या हो सकता है। सो वी हैव हाउ मेनी प्रोसेस, p0 p1 p2 p3। सोचिए, आप लोग थोड़ा सोच लीजिए क्या हो पाएगा।
सर फर्स्ट सर p0
एंटर किया,
दोनों सर चॉपस्टिक उठा लिया।
दोनों चॉपस्टिक उठा लिया, p0 भी खा रहा है।
यस सर। then let p1 enter, then let p1 sir enter, means mutex sir।
p1 एंटर, ठीक है, p1 एंट्री किया,
हाँ,
एंट्री
सर,
किया, सपोज यहाँ पर कॉन्टेक्स्ट स्विचिंग हो गया।
अच्छा ठीक है, हाँ हो गया।
हो पाएगा या नहीं हो पाएगा? फर्स्ट थिंग
सर नहीं, मतलब हो तो पाएगा पर कोई इफेक्ट नहीं
नहीं हो
होगा।
पाएगा। क्यों नहीं हो पाएगा? बिकॉज व्हेन यू थिंक अबाउट दिस, दिस इज माय p0, दिस इज माय p1, दिस इज माय p2, दिस इज माय p3 and this is my p4, and we assume that these are the 0 chopsticks, this is my 1 chopsticks, this is my 2 chopsticks, this is my 3 chopsticks and this is my 4 chopsticks। करेक्ट है? ठीक है ना? सो अभी एक किस चॉपस्टिक को पकड़ा है? दिस एंड यस। सो फॉर दिस p4 he can take these chopsticks, but a उसको नहीं मिला, a उसको नहीं मिल रहा, ठीक है ना? सबको ऐसे ही अलाउ कर दीजिए, तो ये क्या हो गया, यहाँ पर ये फंस गया।
सर वो जब फंसेगा और कोई तो सर म्यूटेक्स में जा ही नहीं पाएगा ना सर।
वही तो प्रॉब्लम है, आप जो बताए आप वही आंसर बता दिए, क्योंकि ये जब फंस जाएगा, अगर इसका ईटिंग खत्म नहीं हुआ है, दिस फेलो आल्सो नॉट एबल टू ईट, जो कि करना चाहिए।
सर वो तो ईटिंग तो सर खत्म हो ही जाएगा ना सर।
नहीं, वो तो बाद में खत्म, अगर वो धीरे धीरे खाया।
सर अगर ईटिंग टाइम अगर फाइनाइट है तो सर तो वर्क करेगा ना सर।
वर्क करेगा, बट व्हाट विल हैपन, दिस फेलो इज नॉट एट ऑल डिपेंडेंट अपॉन p0, बट एज पर योर कोड इट इज डिपेंडेंट।
यस सर।
सर तब फिर वो क्राइटेरिया फुलफिल नहीं होगा शायद, वो क्या सकते।
मतलब ये देखिए,
एक्सटर्नल हो जाएगा फिर,
ए
एक्सटर्नल
इसको
डिपेंडेंस।
इन्फ्लुएंस नहीं डालना चाहिए, सही बोले, ए इसको इन्फ्लुएंस नहीं डालना चाहिए, लेकिन ये इन्फ्लुएंस हो गया तो कौन सा हमारा काम नहीं किया, प्रोग्रेस। इसके वजह से जब तक वो खाना खत्म नहीं कर देता है, मतलब जब तक वो घर से हॉस्टल नहीं आ जाता है, ये लोग हॉस्टल में भी है कि भी खाना मतलब क्लास नहीं कर पा रहे। इन लोगों के पास सब कुछ है, स्पून भी है, क्लास भी है, टीचर भी है, सब लोग है, लेकिन नहीं कर पा रहे।
सर बट ईटिंग टाइम अगर इन जनरल अगर इन्फिनाइट हो गया तो फिर तो सर सभी मतलब कोई काम ही नहीं करेगा, मतलब कुछ।
क्यों? कोई नहीं, वो इन्फिनाइट में नहीं बोलो, ये इन्फिनाइट नहीं बोलो, मैं बोल रहा हूं कि ये 5 दिन के बाद भी आएगा, ये 5 दिन के बाद आएगा, लेकिन 5 दिन के बाद इसको चांस मिल रहा है।
यस सर।
वही तो प्रोग्रेस बोल रहा था ना, प्रोग्रेस
sir.
नहीं बोल रहा था कि ये इंडेफिनाइट के लिए वो हो गया, प्रोग्रेस बोल रहा था कि जब तक वो एग्जीक्यूट नहीं हो जाता तब तक मैं यहां पढ़ा रहा। आप अगर कोड को देखेंगे, आज 1 मिनट में खत्म करता हूं, हम वो कोड को देखेंगे जिसमें सीखे थे कि पीटरसन से पहले ना कहां पर हो रहा था, म्यूचुअल एक्सक्लूजन हो रहा था, कॉन्टेक्स्ट स्विचिंग हुआ था, हार्डवेयर ब्लॉक, यहाँ पे जो जहां पर कंडीशन पड़े थे, यहाँ देखिए, ये P2 was interested but P1 cannot enter, sorry, P2 cannot enter because unless until P1 comes and come here and finish, that's why ये काम नहीं कर पा रहा था। लेकिन P1 तो कभी ना कभी आएगा ना, ऐसे नहीं कि वो पूरा इनफाइनाइट टाइम के लिए नहीं आ रहा है, वो बोल रहा है कि P1 आएगा, लेकिन 10 दिन के बाद आ सकता है, 15 दिन के बाद आ सकता है, वहां पर भी वैसे 10 घंटे के लिए वो खा सकता है, 15 घंटे के लिए, वो तो फिलोसोफर है ना, खा कर ऐसे ही करके खा गया, एक चावल करके खाएगा तो 1000 चावल होगा वो एक। Accepted or not? No. His view has to be satisfied first. Please don't think in the other way.
यस
Are
सर,
you-
मतलब
हाँ।
सर बट ये जो चॉपस्टिक जो है सर वो तो सर साइक्लिक रिसोर्स है ना, मतलब सभी, मतलब जैसे यहाँ पे सर वो साइक्लिक नहीं है ना सर।
वो भी साइक्लिक है इनडायरेक्टली ना, और क्योंकि वहां था बाउंडेड वेट 1 था, आप याद था, बाउंडेड वेट उसका 1 था, मतलब क्या है, वो पूरा का पूरा साइक्लिक है। ए खत्म होने के बाद ए गारंटी जाएगा, क्योंकि ए 0, अगर ए 0 है, ए पहले जाएगा, ए 1 कर दिया तो ए नहीं जा पाएगा, फिर ए जाएगा, ए जब 0 करेगा तब ए जाएगा, ये भी साइक्लिक इनडायरेक्टली, ये भी साइक्लिक। क्योंकि जब भी हम शेयरेबल थोड़ा बनाते हैं ना, थोड़ा सा वगैरह साइक्लिक आ जाता है किसी भी तरह से।
यस सर।
हाँ
सर मतलब ये हम लोग को बनाना है कि मोर देन 1 कैन ईट, वही
मोर देन 1 कैन ईट, नहीं तो उनका सॉल्यूशन तो पूरा सही था, कुछ गलत नहीं था,
हाँ
सॉल्यूशन के हिसाब से कुछ प्रॉब्लम नहीं था, उनका पूरा परफेक्ट था। Only thing is that because of P0, P2 should not suffer and P3 also should not suffer. दोनों फंस रहे हैं, वो तो कोई पसंद नहीं करेगा। ओके ठीक है, मैं बंद करता हूँ, मेरा और एक क्लास है इमीडिएटली। थैंक यू फॉर पार्टिसिपेशन, आई होप अदर्स आर आल्सो पार्टिसिपेटिंग।
एक्सक्यूज मी सर।
यस प्लीज।
सर एक डाउट था मेरा, अब होगा एक क्वेश्चन।
नहीं होगा।
ओके सर, फ्री कब होंगे आप?
फ्री पता भी नहीं है, जाके 4 साढ़े 4 बजे के बाद।
ठीक है सर, ठीक है तब। ओके सर, ओके।
I'm ending, huh? Fine.